Welcome back, Caymans. Mr. Eicher here, continuing and I guess finishing this lesson number 2. This is the third video in this lesson. And we're not going to introduce anything too drastically new in this video. I wanted to use it to do two things. Number one, practice with two-way table probabilities. And number two, review vocabulary and notation. So if you know how to read this math, then really this lesson should be really similar to stuff that you've done in the previous videos. So we have an AP statistics teacher, guess who, asked his students the typical amount of time they spend doing distance homework in the course, AP Stats, and how the amount of time they're spending doing distance learning homework compares to the amount of time they spent on the course before school closed. So this top variable is the same that we had in the last video, but now instead of when you're going to bed typically, how much time you're typically spending on the course in 1 week. So for instance, these students are only spending 1 to 2 hours in AP Stat stuff. And that's actually, surprisingly, I think this is kind of funny. This would mean they're spending more time now on AP Stats, and they're only spending 1 to 2 hours. So that's kind of surprising, but maybe we'll talk about that a little later on another part. Okay, so the first question we have is find the probability. That P right there, that's just a really short way of saying what is the probability that ... Mathematicians love to use symbols to abbreviate things. So they're like, hey, probability starts with a P. Let's just use a capital P with parentheses. And then in parentheses is called the event of what's actually occurring. The event is that they spend less time in their AP Stats distance learning work. So less time, that would be 18 students out of 50. The probability would be 18 out of 50. Now, if you want to write that as, what is that, 36% or 0.36, you could write it any of those ways are acceptable ways. So if you're doing an assignment, just make sure that you follow the directions closely, how we'd like you to type your answers. Next question, the probability that you pick a student who is spending less time, I already have that one circled, and the same time. Oh, less time and the same time. Okay, so that would be probability they're spending less time and the same time. Well, wait, probability you spend less time, there's 18 students there, and that they're spending the same time, there are 19 students there. You can't be both. No student is spending both less time and more time. So this really doesn't make sense. These events are mutually exclusive. So really the answer is like undefined or basically 0%, because you can't do both. Now that's different. That might make you feel a little uncomfortable, but that's different. What you're probably thinking is to answer this next question. What's the probability they spend less time or more time? So you could be one or the other. You don't have to be both. So in this case, the less time people, that's 18. The same time people, that's 19. So when we add them out of 50, we get 37 out of 50. Now that's possible. That makes sense. But this word and makes it weird because you can't be spending less time and the same time. It's one or the other. All right, so let's look at the next one. We have probability they're spending less time. Probability they're spending less time, so that would be these people. Or 3 to 7 hours, that's these people. Now, are these events mutually exclusive? We have these less time people. We have these 3 to 7 hour people. Notice the overlap here. Notice that overlap that occurred right there. These are not mutually exclusive. And because they're not mutually exclusive, we have to subtract the overlap. So the less time people, that would be 18 people. The 3 to 7 hours that they're spending is 32. But we have to subtract these 17 people that we double counted. Now, rather than doing it that way, you could always just count and add, right? You could just add 6 plus 9 plus 1 plus 17 plus 0 and get the same answer. So that would be what, 33, I think? The answer should be 33 out of 50 or 66%. All right, and then we have the probability that we pick 2 students who are less time students without replacement. So 2 students who are less time, that would be these students. So the first student, let's draw 2 sets of parentheses because we have 2 students that we're selecting, whereas all the previous ones, we just had 1 student. How many less time students? There's 18 out of 50. And pause the video and see, can you figure out what this next fraction is going to be? The next fraction, since it's without replacement, you've selected 1 student here. That means you have 49 students left. And you've lost a student from the numerator because one of your less time students has been selected. So you have 17. And then multiplying those, we get 18 out of 50 times 17 out of 49. And that would be 0.125. I'm multiplying that. So that's the probability. Let's do the same thing on the next one, but now we have 2 students are less time with replacement. So again, we have 2 students, so let's have our 2 fractions that we're going to multiply. And the first fraction is 18 out of 50, like before. And what would the next fraction be? Since it's with replacement, you can get the same student again. So you still have 50 students after you've selected that first student, because you could pick them again. And you still have 18 who are less time students. So we'd have 18 out of 50 times 18 out of 50, and that gives us approximately 13%. So the answers are pretty close, but they're not the same answer, slightly different. And then this last part, based on this table, I want to talk about this notation. This line right here, that line right there, that's given that. This line also indicates that this is a conditional probability. So we did conditional probabilities in the previous video. But the condition is the 1 to 2 hours. So I love conditional probabilities because I get to do the shading of the table. You could do this mentally, but since I can erase pretty quickly, I will just shade the table. So we want given that it's 1 to 2 hours. So I'm going to ignore all of these. And I only want the 1 to 2 hours. So what's the probability just among those people? That's it. Among those people, what's the probability they are less time? Well, that would be there's 1 out of 4. So there's a 25% chance that you would get a less time student given that they're a 1 to 2 hour amount of time that they're spending on homework. Okay, let me erase this. Why don't you pause the video and see, can you answer this next conditional probability? So first, what should we get rid of? Well, our condition is the 8+ hours is what we want. So we're going to get rid of everything that isn't in that row of 8+ hours. So we're just looking at these guys. And more time is what we're looking for. So more time is 5 out of 8+ hours. And there's 14 students who are 8+ hours. So That's our answer. That's our conditional probability. I wanted to ask B and C based on this because it is kind of interesting data that I was looking at earlier or mentioning earlier. A teacher wants to present his case that he should be assigning more work during distance learning than he had before he collected the survey responses. Which cell from the table, which box from the table, could he use as evidence of his claim? So if I wanted to argue that I should be assigning more work, so let's see, what cell would be good? So these students say they're spending less time on the homework now. So if they're spending less time, that would mean, oh, should probably assign more work. And notice there's, no students are spending more than 8 hours. So maybe I would pick, maybe I'd just go with these. Maybe I'd say 18 out of 50. So maybe I could argue, dear Mr. Moen, only 36% of students are spending 1 to 7 hours on work. And that's less than usual. So I should assign more work. Seems like a big chunk of students, 18 out of 50. Now, to be fair, I have a follow-up question. A group of students don't like to hear that. A group of students want to provide evidence against the teacher's claim. What cell could the group use in their counter-argument? Well, let's see. If they want to argue, we're spending more time on homework, probably wouldn't want to include these students. That might not be the best argument, right? I'm spending a lot more time. Really? How much time are you spending? 1 to 2 hours. I don't know. But it seems like the strongest argument would be 6 or 5. Maybe you could throw in 6, but that would be a lot. Like they're spending a lot of time on distance learning, more time than they would have if they were in a classroom setting. So maybe the 5 out of 50 we could use. So maybe our claim would be, hey, 10% of students are spending more time than before, like 8+ hours a week. This is way too much. So that's just looking at the table and assessing a claim, trying to find a counter argument, things like that. And don't worry, we won't assign more work in your class. But hey, AP Stats, maybe I did. Maybe I didn't. Anyway, and we'll end this video just a couple of terms that I hope that you better understand as a result of these past couple of videos. Some sophisticated terms for probability stuff. Union, anytime you have an or probability, this is called a union. The symbol for that is a U for union. So you could see something like probability 9th grader or a male. So that would be a union. An intersection would be, what's the probability of picking a 9th grader and one that's also a male? So that would be the symbol for intersection, which is upside down U, which looks kind of like an A for and. Mutually exclusive events are events that can't happen at the same time. So the example I gave in a previous video, here's all the 12th graders, here's all the 9th graders, and notice there's no overlap. If you can't be both events at the same time, those are mutually exclusive events, sometimes abbreviated ME, mutually exclusive. Conditional probability, the notation is this little line where B is your kind of your new denominator. Instead of using the total, that's your condition. You're only looking at that group, the B people, and then calculating a probability. And then without replacement versus with replacement versus without replacement. The effect that this has, the total number, like in the denominator, will reduce, and sometimes the numerator, depending what the event is, numerator. Whereas if you have with replacement, the denominator remains the same. With replacement is you can pick the same person again, for instance, a second or third or fourth time. So those are just some things that we've covered through these videos. Thanks for watching. Give me a thumbs up if you like the video. Please email or message if you find any typos or mistakes or have any questions. I appreciate all the feedback that I've gotten. And I hope you have a great day, and I'll see you next time.